Dear learners, I am Gaurav Kumar Agrawal, Assistant Professor at UTD CSVT Bhilai. In today's session, we are advancing to the topic of damp proofing and termite treatment. We will explore the causes, effects and the treatment of dampness in buildings. We will also know the causes of termite infestations and their treatment. By the end of this session, you will gain a good understanding of preventing the building from dampness and termite infestations. We will discuss the following key points. First, we will know the introduction to the damp proofing, then causes and effects of dampness, then methods and materials used for damp proofing, then DPC treatment in buildings, then introduction to the termite treatment, then anti-termite treatment. So, first we will know the introduction to the dampness. A critical aspect of any building's design is ensuring that it remains dry and free from moisture intrusion through its walls, roofs or floors. Dampness refers to the presence of moisture within building elements which can be caused by both hygroscopic and gravitational forces. The occurrence of dampness not only results in unsanitary conditions but also weakens the structural integrity of a building. Hence, damp proofing is a vital consideration in building design as it helps to prevent moisture penetration. Implementing effective damp proofing measures ensures the long-term durability and strength of the structure. Then what are the various causes of dampness? Here are some of the key causes of dampness in buildings. First is moisture rising from the ground. All buildings are constructed on soil foundations which are constantly in contact with the moisture. If the soil is permeable, moisture moves through it readily. Even in cases where the soil is relatively impermeable, substantial moisture may still be present, which can rise into the structure through capillary action. Groundwater movement can infestations this issue, causing moisture to rise into the building through the walls and the floors, leading to the damp conditions. Second is rainwater entry from the top of the walls. Rainwater can penetrate the top of the walls if they are not adequately protected, leading to the downward movement of moisture within the wall. Similarly, leaks in the roof allow water to infiltrate, which can spread to adjacent areas and cause dampness within the building. Then the third is rain impact on external walls. Heavy rainstorms can cause water to batter against the exterior surface of the walls. If these walls are not adequately sealed or treated, moisture will permeate the structure, leading to dampness within the interior spaces. Additionally, poorly designed balconies or chhajjas projections with inadequate drainage can result in water accumulations, which may eventually seep into the walls, causing moisture related damage. This kind of dampness can severely damage interior finishes and decorations. Then the fourth is moisture due to condensation. Condensation occurs when atmospheric moisture comes into the contact with cooler surfaces, leading to water deposition on walls, floors and ceilings. This deposited moisture can cause dampness over time if left unchecked. Then what are the miscellaneous causes of dampness? Moisture can enter a building due to several other factors, including poor side drainage, second improper orientation causing walls to receive less sunlight and retain dampness after rain. Third is inadequate roof slope, particularly within the flat roofs. Fourth is construction defects such as faulty joints in walls or roofs. Fifth is water absorption from damaged rainwater pipes. Then what are the various effects of dampness? Dampness in buildings can lead to several detrimental effects impacting both the structure and health of its occupants. Some of the major consequences of dampness include: first is health hazards. Damp environments create favorable conditions for mosquito breeding, contributing to the spread of diseases and creating an unhealthy living environment. Second is unsightly patches. Moisture traveling through the walls and ceilings can lead to unattractive and discolored patches, which can diminish the aesthetic appeal of the interior spaces. Third is plaster damage. Prolonged exposure to moisture can cause the plaster, especially lime-based plaster, to soften and crumble, leading to structural damage. Fourth is damage to the wall finishes. Dampness can ruin interior wall finishes such as paint or wallpaper, making repairs difficult and expensive. Fifth is explorences and structural weakening. Continuous moisture presence in walls may cause efflorescences, leading to the disintegration of bricks, stones and tiles. This weakens the building's structural components. Then the next is flooring damage. Moisture can reduce the adhesion of flooring materials, causing them to loosen and degrade over time. Then the next is damage of timber fittings. Wooden components like doors, windows, wardrobes and cupboards that come into the contact with damp walls or floors may warp, buckle or rot, causing extensive damages. Then the next is electrical hazards. Moisture can deteriorate electrical fittings, increasing the risk of electrical leakage and potentially leading to dangerous short circuits. Then the next is damages to the floor coverings. Floor coverings cannot be effectively used on damp floors, as they may become damaged or unusable over time. Then the next is termite infestations. Dampness accelerates the growth and spread of termites, which can cause extensive damage to the wooden elements of the building. Then the next is health risk from germs. Dampness combined with the warmth and darkness can breed harmful germs that lead to serious diseases such as tuberculosis. Occupants also experience respiratory issues like asthma. Then the next is corrosion of the metal fittings. Moisture can lead to the rusting and corrosion of the metal fixtures attached to the walls, floors and ceilings, further weakening the structure. Then what are the various methods of damp proofing? Following methods are adopted to make a building damp proof. First is use of damp proof course, that is also known as DPC. Second is integral damp proofing. Third is surface treatment. Fourth is cavity wall construction. Fifth is gunniting. Sixth is pressure grouting. So first, membrane damp proofing, also known as DPC. This method involves placing a water resistance membrane, also known as a damp proof course. In short, it is known as DPC, between the sources of dampness and the adjacent building components. The materials used for DPC include bitumen, mastic asphalt, bituminous felts, plastic or polythene sheets, metal sheets and cement concrete. DPC can be installed both horizontally and vertically in walls and floors. Key guidelines for the DPC application include: it should cover the full thickness of walls excluding external rendering. The supporting mortar bed must be smooth, level and free from projections to avoid any type of damages. DPC should be continuous across junctions and corners for the complete protection. When transitioning from horizontal to vertical surfaces, a cement concrete fillet of approximately 7.5 cm radius should be provided at the junction. DPC should be exposed to avoid damage during construction. Then the next is integral dam proofing. In this method, dam proofing compounds are added to the concrete mix, making it impermeable. These compounds come in different forms, like first is filler compounds. Materials such as chalk, talc and fuller's earth fill the voids in the concrete. Second is chemical reactants. Alkaline silicates, aluminum sulfates and calcium chloride react with concrete to form water resistance compounds. Third is water repellents. Compounds like soap, petroleum, oils and stearates work by repelling water, preventing moisture absorption into the concrete. Commercial products such as Pablo, Permo and Silica are commonly used in the integral dam proofing. Then the next is surface treatment. Surface treatments involve applying water repellent substance to the areas through which the moisture enters. Metallic soaps like calcium, aluminum oilates and stearates can be applied to external surfaces to prevent rainwater penetrations. Exposed surfaces should be carefully pointed and plastered using waterproofing agents like sodium or potassium silicates and zinc or aluminum sulfates. Surface treatments are effective for superficial moisture but may not work well under pressure. In some cases, exposed brick or stone surfaces may also be sprayed with water repellent solutions. Then the next is cavity wall construction. This method involves creating a cavity between the main structural wall and an outer protective skin wall, effectively preventing moisture from penetrating the building. The cavity acts as a barrier, reducing the risk of moisture transmission. Then the next is gunniting. Gunniting is a process that applies an impermeable layer of rich concrete mortar over exposed surfaces to protect against water penetration. A cement sand mortar mix, typically in a ratio of 1:3, is sprayed onto a cleaned surface using a high pressure cement gun. The mixture is applied at a pressure of 2 to 3 kg per centimeter square, with the nozzle held about 75 to 90 centimeter from the surface. This creates a thick, durable and impermeable layer that should be properly cured for at least 10 days. Then the next is pressure grouting. This technique involves injecting cement grout under pressure into the cracks, voids and fissures in structural elements or the foundations. The pressurized grout consolidates the structural components, making them resistant to moisture penetration. This method is especially effective for preventing groundwater seepage into the building foundations and the substructures. Then what are the various materials used for dam proofing course? For effective dam proofing, the materials used must meet certain criteria to ensure long lasting protection against moisture. A suitable dam proofing materials should have the properties such as impervious. The materials must be completely waterproof, preventing any moisture from penetrating or passing through. Second is durability. It should have a long life span, ideally matching the longevity of the building itself. Third is strength. The material must be able to withstand the load and the pressure exerted by the structure above it without collapsing or damaging. Fourth is flexibility. It should accommodate minor structural movements without cracking or breaking, ensuring its effectiveness over time. Then the next is affordability. The material should be cost effective without compromising on its quality and performance. Then the next is seamless jointing. It must allow for the leak proof joints, ensuring that no gaps or openings exist where moisture can seep through. Stability. Once applied, the material should remain fixed in places and not shift or move, ensuring consistent protection. Here are some of the commonly used materials for damp proofing courses. First is hot bitumen. Hot bitumen is a commonly used waterproofing material due to its strong adhesive properties. When applied hot, it forms a continuous and impermeable layer, effectively preventing moisture penetration. Second is mastic asphalt. Mastic asphalt is a durable and flexible waterproofing material that is commonly used for damp proofing. It provides a seamless and impermeable layer, ensuring no moisture seeps through. It is often used on flat roofs and floors. Third is bituminous or asphaltic felts. These materials are made by impregnating hessins or fiberglass mats with bitumen or asphalt. They are applied in layers and provide excellent moisture resistance, making them suitable for walls and roofs. Fourth is metal sheets. Metal sheets such as lead, copper or aluminum are highly durable and impermeable, providing strong protection against the dampness. However, these may require careful installation and prevent corrosion and joint leakage. Fifth is combination of sheets and bituminous felts. In some cases, a combination of metal sheets and bituminous felts is used to enhance waterproofing. This layered approach offers both flexibility and strength, making it ideal for areas exposed to heavy loads or movements. Sixth is bricks. Bricks with low permeability such as dense engineering bricks can be used as a damp proof coats. They prevent moisture from rising through capillary action, making them effective in preventing dampness at the lower levels of the walls. Then the next is stones. Certain stones like slate are naturally resistant to the moisture and can be used for damp proofing. They are commonly applied in older constructions where traditional materials are preferred. Next is mortar. Waterproof mortar can be used in damp proofing by mixing water resistant compounds like aluminum or zinc sulfates. This provides a protective barrier that prevents moisture from seeping through masonry joints. Next is cement concrete. A dense layer of cement concrete, often reinforced, can be applied as a damp proof course. When mixed with waterproofing additives, it forms a strong and impervious layers, particularly suitable for foundations and floors. Next is plastic sheets. Plastic sheets such as polythene are flexible and affordable options for damp proofing. These sheets are lightweight, easily to install and provide an effective moisture barrier, particularly for floors and the walls. Then the next is damp proof course DPC treatment in buildings. Effective damp proofing is essential to prevent moisture from entering the structure, which can cause significant damage over time. Various methods and materials are used to ensure that different parts of the building remain dry and protected from dampness. Here are some of the key treatments for various parts of a building. So, first is treatment of foundations against gravitational water. Foundations are prone to water that percolates from the adjacent ground. This moisture can rise into the walls through capillary actions. One method to prevent this is by installing an air drain parallel to the external walls. This drain, typically 20 to 30 cm wide, keeps the wall dry by preventing water from seeping in. The outer wall of the drain is kept above the ground level to block surface water. Additionally, a reinforced concrete RCC slab is provided, and opening with grating are installed at regular intervals to allow air circulation. Horizontal and vertical damp proof courses are also provided to further protect the structure. Then the next is treatment of basement. Basements, especially those in damp soils, require specialized treatment to prevent moisture infiltrations. There are three primary methods for damp proofing basements. First is foundation drains and DPC. In poorly drained soils such as peat and basement, it is prone to continuous water increase due to the hydrostatic pressure. A trench is dug around the foundation and filled with gravel and other porous materials. Open jointed drains are provided to collect underground water, and horizontal and vertical DPC layers are applied to both the foundations and the walls to prevent moisture rise. Drain pipes may also be installed beneath the basement floor to further enhance the drainage. Next is RCC raft and wall slab. In cases where underground water pressure is severe, drainage system alone may not be effective. Instead, a rigid reinforced concrete RCC floor slab and wall slab are constructed to create a waterproof barrier. Horizontal and vertical DPC layers are added, and multiple layers of bituminous felts are used to enhance water resistance. An outer protective half brick wall is constructed to shield the RCC wall from damage. Then the next is asphalt tanking. When the subsoil water table is relatively low, asphalt tanking is an effective method. A 30 mm thick asphalt layer is applied horizontally over the entire basement floor, extending up to the external walls as a vertical layer. The vertical asphalt layer is of 20 mm thick and provides a waterproof barrier. A protective brick wall is constructed around the exterior of the basement walls to shield the asphalt layer. The vertical DPC is extended at least 15 cm above ground level to ensure complete protection. Third is treatment to floors. In locations where ground moisture is not a concern, the subsoil is compacted and a 7.5 to 10 cm thick layer of coarse sand is spread across the area under the floor. Alternatively, stone soling may be applied, followed by a layer of plain concrete, cement concrete, typically a 1:3:6 or 1:4:8 mix. Flooring can then be laid over this base. However, in areas with high moisture and a water table close to the surface, a membrane DPC is required. Mastic asphalt or bituminous felt is often used for this purpose. A layer of flat brick is placed on a sand cushion to protect the DPC during construction. Before laying the bituminous felt, a primer coat of hot bitumen is applied at a rate of 1.5 kg per meter square to the foundation concrete. After the felt is applied, a finishing coat of bitumen is added to ensure proper sealing. Then the next is treatment of walls. For basement walls, vertical DPC is applied to the external face of the wall. This layer is grouted on a base of water cement plaster and protected by an outer half brick thick protective wall. The vertical DPC should extend at least 15 cm above ground level to provide complete protection. Horizontal DPC is applied at a similar height above ground level on external walls starting from the floor level. For internal walls, DPC is placed at the same level as the upper surface of the concrete floor. If the floor level on either side of an internal wall differ, the DPC is adjusted accordingly to maintain moisture protection. Then the next is treatment of roofs. Roofs are particularly vulnerable to moisture infiltrations, especially during heavy rainfall. Proper DPC treatment is necessary to prevent water from seeping through the roofs and causing damages to the interior of the building. This can be achieved through the application of waterproof layers such as bituminous felt or asphalt across the roof surfaces, ensuring all the joints and edges are sealed to prevent leaks. By addressing these various parts of the building with appropriate DPC treatments, the structure remains protected from moisture, ensuring its longevity and the safety of the occupants. This concludes our dampness treatment. Now we are starting the termite treatment. So, what are the various types of termite? Termites, often referred to as white ants, causes significant damages to the wooden structures and furnishing in the building. The financial loss due to the termite infestations in some countries is estimated to be as high as 10% of the building's total capital investment. Because of this, anti-termite treatments are crucial to either completely prevent or at least reduce the damage caused by these pests. Termites are classified into two main types. First is dry wood termites, second is subterranean termites. So, first is dry wood termites. Dry wood termites live exclusively in dry wood, forming small colonies without any connection to the soil. These termites thrive in humid coastal areas and are primarily found in the coastal regions of the southern India, though their numbers remain very low. Unlike subterranean termites, dry wood termites work through wooden structure only, causing significant damage to the furniture and other wooden elements. Then the next is subterranean termites. Subterranean termites establish their primary colonies in the soil and cannot survive without maintaining a connection to these colonies. They travel through shelter tubes, tunnels or galleries in various materials to search for the foods, primarily wood and cellulose. As they travel, they coat these tunnels with the soil for protections. Subterranean termites require moisture for survival and typically enter the buildings through foundations, progressing upwards through the floors and the walls, destroying everything in their path. They can also travel through cracks in the masonry and the flooring. Subterranean termites are the most common type in the northern India and are known for forming extensive colonies underground. Sometimes they establish nests in stumps of the dead trees or build dome-shaped mounds on the ground. These termites require both moisture and darkness to survive. Their colonies are structured into the following five castes. First is queen, it is responsible for the reproduction. Second is king, the male counterpart to the queen. Third is soldiers, protect the colony. Next is sexual winged adults, responsible for establishing new colonies. Next is workers, forage for food and maintain the colony. Dear learners, we have reached the end of today's session. I hope you found it informative and engaging. Thank you for your attention. See you in the next class. Thank you.